All right, this is Math 209, Week 3, Section 7.3, Subtract. And basically, this is a fancy way of saying we're going to be subtracting fractions. All right, so when you are subtracting fractions, you just have to remember that's kind of like 9/7 minus 6/7. And all you have to do is you subtract the numerators because you need a common denominator. And we already have a common denominator. It's a 7. So the 7 just comes over. And 9 minus 6 is 3. So the idea is 9/7 minus 6/7 is equal to 3/7. Assuming you have a common denominator, right? And so using algebra, it's the exact same story. So we're going to copy the problem down. So you've got 10 plus 3x over 6x minus 10 over 6x. And the idea is, look at that, we already have a common denominator. So we know our denominator is 6x, and our numerator is 10 plus 3x minus 10. And so we see that, well, 10 minus 10, so 10 minus 10, that equals 0. And so our, I'm going to go down here. So our numerator becomes 3x over 6x. Now that I've got that far, now I want to think about, well, can this fraction be reduced or simplified? And sure enough, it can, because I want you to think of that 3x as 3 times x, and then I want you to think of this 6x as 2 times 3 times x. And so sure enough, we've got x over x, that equals 1, 3 over 3 equals 1, so our fraction ends up being 1 over 2. And so that's our answer for this problem. So that original problem is equal to 1/2. All right, so we've got another problem where we are supposed to subtract, and you'll notice we already have our common denominators. So when we take a look at that problem, we know that our denominator is still going to be 9z plus 5. And then our numerator is going to be 10z minus z. Now, a lot of students in algebra suddenly kind of forget and they think, oh, 10z minus z is equal to 10 because the z's cancel out. No. 10z minus z equals 9z over, and then you've got 9z plus 5. The other thing is you're not allowed to cancel the 9z and the 9z because this is not a 9z, this is a 9z plus 5, all right? When it's connected by a plus or a minus, this whole thing has to be treated as a number or as a factor, all right? And so there is our final answer. So subtracting these two fractions, pretty straightforward because we already have our common denominator. What's tricky, however, is going to be our signs. We're going to get our signs really confused. It's pretty typical in Math 209. And here's why. Okay, so the idea is we know, let's see, how am I going to write this down? Oh, I'll just go straight below. We know that our common denominator is 3a plus 3. So that means we're just going to have this term or expression, a squared plus 18a minus 1, and then we're going to subtract the a squared plus 6a minus 13, all right? And that's the idea. It's going to be this term minus this term, all over 3a plus 3. And the idea is this minus sign means we have to distribute the negative. And we did that in 208. So this becomes, now because there's no coefficient in the front and it's a positive, that means this first term we can just totally ignore the parentheses and just drop the parentheses. So there we go with that. But then here, this becomes minus a squared, and then this becomes minus 6a, and here's the trick, and this becomes plus 13. So it's the opposite. This was positive, it becomes negative. This was positive, it becomes negative. It was negative, it becomes positive. And all of this is still on top of the 3a plus 3. And so as we're simplifying now, we want to notice that, oh, look at this. A squared minus a squared. They cancel each other out. And then we've got positive 18a minus 6a. So that ends up being 12a. And then we've got, oh, let's do it in green, minus 1 plus 13. So that equals plus 12. All over 3a plus 3. All right. So now that's the answer, but we can simplify. And so we can see that that numerator can be has a common factor of 12. So that ends up being 12 times a plus 1 over. And we can see that this down here, these two terms have a common factor of 3. So it becomes 3 times a plus 1. And now we can see we have a common factor of a plus 1 over a plus 1. And I see that 12 over 3, that can really, if you want to think about 12, you could think of 12 as 4 times 3. So we have a common factor of 3 over 3. So this is 1, this is 1. So our final answer is just 4. So the crazy thing is that, oh gee whiz, this original, whoa, yikes, that original expression right here is equal to 4. So we already have common denominators. So you've got m minus n over 14 minus, and then you have m plus n over 14. And what makes this question so tricky is just the fact that we're going to get our signs messed up. So this becomes m minus n minus m plus n over 14 because we already had our common factor. I'm sorry, common denominator. And then because there's no coefficient in the front and there's no sign, so it's positive, that means we can just drop the parenthesis for that first portion. But this guy right here, that is the distributive property. So negative, this becomes negative m minus n all over 14. And so let's see, where's our common terms? Well, here's a positive m minus m, so they cancel each other out. Here's a negative n minus n, so that equals negative 2n over 14. All right, we're not quite done because we know that 14 can be thought of as 2 times 7. And so this 2 cancels with this 2, so our answer ends up being negative n over 7. All right, now that's the tricky part because this was really a negative 2. And if you want to think of it, you could think of this negative 2 as negative 1 times 2. And so that's why this 2 cancels with this 2, leaving us with that negative 1 times n, leaving us with negative n. And then our denominator is, we're left with just that 7. And so there is our answer. So this expression right here is equal to negative n over 7. All right, so to subtract, we see that we already have common denominators. So really all we have to do is we have to subtract. And so we end up with, and this one's pretty straightforward, x minus 3 is in our denominator. And then our numerator ends up being x squared minus 6x plus 9. Now technically we're done because that's the answer, but we have to think about simplifying, all right? And so what we're going to do is we're going to take this expression, x squared minus 6x plus 9, this trinomial, and we're going to go way over here to the box method. So you've got x squared minus 6x plus 9, and we have to do the box method because we want to see if this could be factored. So this becomes x squared and positive 9. So that means we get x and x. We're going to guess 3 and 3. When we get our internal terms, we end up with 3x and 3x, but we want the answer to be negative 6x. So how do we get negative 6x? That means both of these have to be negative 3x's, which makes both of these negative 3's, and sure enough, negative 3 times negative 3 gives us the positive 9 that we're looking for. So this ends up being x minus 3 times x minus 3, all right? And so we're going to take that piece of information and we are going to, let's see, I'm going to go right here. And we're going to replace this expression with x minus 3 times x minus 3. And that's all on top of the x minus 3 as the denominator. And we see, hey, an x minus 3 cancels each other out. And so we end up with, as our final answer, x minus 3. All right, so we're going to subtract. And this is question 6. And we see that we already have common denominators, so all we have to do is copy the problem down. And we see that subtracting is actually fairly straightforward right now because we already have our common denominators. So that 4x plus 1 just comes over. And now up here, we can do this in our head. This is going to be 4x squared minus 19x minus 5. And now what we need to do is we need to see if we can factor this numerator to see if anything cancels. So 4x squared minus 19x minus 5. I got to memorize that, and I'm going to go over here. So I've got 4x squared minus 19x minus 5. And we want to use the box method. And we know that 4x squared goes here. We know that negative 5 goes here. And I'm going to guess that this is going to be a 4x and an x. And then I think I'm going to try 5 here and 1 here. All right, let's see if that works. So let's find out our internal terms. So we end up with 20x and 1x. Now I'm hoping for a negative 19x. And can we get a negative 19 using these two terms? Yes, we can. That's a negative and this is a positive, which makes this 5 a negative 5. And it makes this 1 a positive 1. So our expression, our factored expression over here becomes 4x plus 1 times x minus 5. So that is our factored version. So I'm going to go back over to our problem and I'm going to zoom in, and we now know that this guy right here can be factored to this, right? These two guys are the same thing. This and this are the same thing. I just factored it. So I'm going to move this down a little bit, shrink it a little bit. And so what we end up with is equals this. So we've got 4x plus 1 times x minus 5 over 4x plus 1. So this denominator just comes down, and I've taken this numerator and I've factored it. And I see that this guy over this guy equals 1. And so our answer, our final answer, is x minus 5. So this original expression is simplified as x minus 5. So we've got this really ugly subtraction problem, but fortunately we already have common denominators. So what we're going to do is, here's our problem. And we know that our denominator is going to be a squared plus 2a minus 3, because that's the denominator in both cases. Now our numerator, we've got a squared plus 5 minus 6. Well, we could do that in our heads. That becomes a squared minus 1, because positive 5 minus 6 gives us negative 1. Now I'm going to shortchange this a little bit. You may need to use the box on scratch paper, but that a squared minus 1, that's a difference of squares. So I know that that's going to be a plus 1 times a minus 1. And our denominator down here, that's going to be a plus 3 times a minus 1. All right, that's our factored form. So how did I get that? I used a box, and I used the box method, and that's how I used the box, and that's how I factored this expression into a plus 3 times a minus 1. Now I'm going to look for common factors, and I see that I do see that I have a common factor of a minus 1 over a minus 1. So right here, a minus 1 over a minus 1. So I know that that is equal to 1 whole right there. And so our final answer is the fraction a plus 1 over a plus 3 right there. So that original expression simplifies to a plus 1 over a plus 3.